Hello everyone, welcome to this channel, and today I'm going to discuss about the influence of pH on passive diffusion. We know that most of the drugs are weak electrolytes, so their ionization is pH dependent, and we can write the ionization of a weak acid HA, for example HA, by the equation pH equals to pK plus log of A minus divided by HA. So here pK is the negative logarithm of the acidic dissociation constant of weak electrolyte, and if A minus equals to HA, that is the concentration of the ionized drug is equal to the unionized drug, then in this case you can write pH equals to pK, that is here A minus divided by HA equals to 1. So pK is equal to the pH at which the drug is 50% ionized. So if pH is increased by 1 scale, we can write log A minus divided by HA equals to concentration of A minus divided by HA equals to 1, or A minus by HA equals to 10. Or if it is decreased by 1 scale, then you can write A minus divided by HA equals to 1 by 10. Example of weakly acidic drugs are potassium penicillin V, which forms salts basically with cations. So they are ionized in the basic pH mostly and remain unionized in the acidic pH. Example of weakly basic drugs is atropine sulfate. They form salt with an ion, so they are ionized in acidic pH and remain unionized in basic pH. So we know that the biological membranes are consist of lipids, so the ions are lipid insoluble, and so there always exists a difference between the distribution of the drug in either side of the membrane. So there are certain implications of this pH. Example is acidic drugs. Example is aspirin with a pK of 3.5 or more than 3. They are largely unionized at the gastric pH and they are absorbed from the stomach. Conversely, basic drugs, example is atropine, they are largely ionized at the acidic pH, but they are unionized in the basic pH, so they are basically absorbed from the intestine. Now, aspirin sometimes cause gastric mucosal damage due to the pH difference. The ion trapping of aspirin occurs, and which causes the mucosal damage inside of the stomach. Now, basic drugs attain the higher concentration in the plasma because it has the slightly basic pH, that is 7.4, where the drug remains unionized. In case of urine, if we make the urine alkaline, the acidic drugs will excrete easily, and if we make the urine acidic, the alkaline drugs will excrete easily. There are also some soluble electrolytes, non-electrolytes. Example of such thing is ethanol, and it can readily cross the biological membrane because the transport of ethanol is pH independent. So this is a basic discussion regarding the influence of pH on passive diffusion, and here I am ending my today's discussion. See you in my next video, and if you guys like the videos, please subscribe the channel. Thanks for watching.